Let's say you want to move a game object from one place to another in Unity. Then you would have to use vectors. Vectors come in very handy dealing with player movement and many other stuff. Today I'm going to explain what they are from and how to use them from the basics. So let's start with what are vectors. A vector is an object that has a particular magnitude and direction. So let's take an example. This graph over here contains a game object, so its positional vector would be 4, 3, 4 from the x-axis and 3 from the y-axis. And the direction would be towards the northeast, and this would have a magnitude of 5 units. Here is the formula to calculate the magnitude. It's basically derived from the Pythagoras theorem. So a vector is just not a point in the whole space or local space, but a line from the origin of the coordinate system to that point. So now let's use them in Unity. Before jumping into that, you must know what is global space and local space in Unity. This concept is a bit important when dealing with vectors. The global coordinates refer to the position of the game object in the whole space. It could be over here or over here, and this position would be displayed in the inspector. But when a game object is not a child of any game object and existing individually. But when the game object is parented under another game object, the coordinates shown in the inspector are local and they show the distance from the parent and not the global coordinates. And when you get to transform that position in the scripts, this returns the global coordinates and not the local ones. I'll left you links in the description to know more about this concept, and this is a bit important when you're dealing with vectors. In Unity, multiple dimensional vectors exist, but only Vector2 and Vector3 are most important and used ones. And remember that they are classes defined in Unity's framework. To create Vector2 or Vector3, you can type in new vector, the parameters, and you can store it in a variable which is of a vector type. And now let's discuss about vectors. And now let's start with Vector2. Vector2 refers a vector which has a direction and magnitude in the x and y axis. For example, the line drawn over here using the debug.drawLine command over here is a Vector2 type. You can see it has a direction and magnitude in the x and y axis. Have predefined functions like Vector2.down, which would return a vector which is downwards, and you can use that vector to apply force in downwards direction. Similarly for up, right, and left. And a Vector2.0 would return the origin of the coordinate system. And Vector2.normalized gives a vector whose value is 1 and it's in the same direction. Let's say you have drawn a vector2 which is 6, 6, and when you do Vector2.normalized, it gives you 1, 1. The magnitude is 1, but it keeps the same direction. Vector3 refers to a vector which has direction and magnitude in the x, y, and z axis. When you create a Vector3 with only 2 parameters, the z component is taken 0 by default. And if you would add force, let's say you would add a force of 6, 0, 0, then the game object would move in the x-axis. And now let's see how to use vectors to add force to game objects, move them in various directions, and etc. But before that, let's see how vector math is done so that we can use vector maths to use those methods. In vector maths, you can subtract, add, find the dot product and scalar product of two vectors. For now, let's see how subtraction of vectors work. Let's say you have a vector 2, 5, 5, and another vector 2, 4, and when you subtract these vectors, the Unity or C# would return a vector whose magnitude is equal to the distance between them. In a similar way, addition would work. You can also cross-check this by finding the distance manually. Now let's see some examples where vectors are used. So the first one would be add force. Add force takes a vector which will specify the direction and magnitude to which the force should be added. And let's do it, and I'll explain after once we have did it. And now we can even check the magnitude of this vector by using a method called dot magnitude. Let's do that too. And to calculate the magnitude manually, you can use Pythagoras theorem, and you can use 100 as the sides of the right angle triangle, and the value of the hypotenuse would be the value of the vector. And now let's run this code and see what happens. So I'm hitting W on my keyboard, and a force of 141.42 gets added. The object doesn't move much because of the mass. You can toggle the values in the rigid body component and it will work as you wish. And now let's add a vector which will move the game object perpendicular. So as we have to move the game object vertically, we need to add the force only in y direction, and we shouldn't add force in x direction. And now let's run this code. And now when we hit play, and now when I hit my W key, it moves perpendicularly. And if you want to increase the magnitude, you can increase it by changing the value of the vector to from 300 to 1000 or something. Now in the same script, we're going to give velocity instead of adding force. And now if we want to move it only in the x-axis, we can give a value in the x-axis and leave y as 0. Let's say you want to give a higher speed, then you can increase the magnitude by increasing the value in x-axis. For now, 10 is good. And now let's run this code. When I hit W, the game object moves with a constant velocity of 10. Now you use vectors to give velocity, add force, and there are many other methods. Move towards, lerp, and etc. I've given links in the description. You can view how to use those methods in the documentation. And now let's see a few other methods which we can do with vectors. So the other two methods are, one is to find a distance between two vectors, and another is to find an angle between those vectors. First, I'm going to draw the two vectors using the unities in the command, and then I'm going to show the angle and the distance between them in the debug or the console. And now let's run this code. So once you enable gizmos, you can see a blue line over here, and you can see that the magnitude of that line would be 7 because we have chosen the vector 43 and 50, and in the y axis it's going to be the same. It means they're going to be in the same height, and the distance between them in the x-axis would be minus 43 minus 50. Minus 43 minus 50, which would be 7. So magnitude is 7, and the angle between those vectors is nearly 2.5, which is also nearly 0 because we have given the y-axis vectors the same magnitude. So the angle was nearly 0, and we can clearly see a line from the position minus 4315 and this position, because the above that draw line takes the ending of a vector and to the ending of another vector, and it draws a line, and the math of infinity just states that it should be for infinity time or the max time, and it shouldn't get destroyed after a certain period of time. For vector 3, the whole concept is same, but you can add force or give velocity in the z-axis too. And you need to remember that the position of any game object is a vector 3 in, let's say it be 2D or 3D, and in this way it's going to move in the x, y, and z axis when you use vector 3s to add force or move the game object using different methods. And a very common example where vectors are used is the default player movement or the basic player movement in many games. And here is how you can do that you understood how to use vectors and what they are. Any doubts, you can ask them in the comment section. Thanks for watching.